but actually they only match 1/4 of the time. The easy example would be if they didn't match at all. Then you would have to say, sir, in either case, that something happens, that when you push this button, if they were red, green, green was a set that they would have made if I had pushed them, then when I push this one, I must change it somehow because the experimental result is 1/4 of the time. So when I push this, the only way to explain that is to have a machine that if I push one button, it changes the ones underneath. Now, if we go to nature and look at it and say, well, what happens if I looked at all the buttons at the same time, that I pushed this and got the result and pushed that and found all the results will always repeat. For example, nothing would ever change, then I'd be in a pickle. So, but it is true that we're only allowed to push one button at a time, and furthermore, it does turn out that when we push a button, let's say this one, and gets red, then this one is green, say, and we push this one again, it's no longer red. So we have experimentally noticed that it is true. It's quite possible and perfectly true that we could imagine it this way, that when we push the buttons, they change the colors of the other lights. I remind you, if you push the same button again and again, it always checks out the same color. I start out and make sure this is red by pushing it 8 times. Then I push this one, it's green, it'll stay green all the time, say. Then if I push this, it's possible that it be green now. Okay? Otherwise, I'd never be able to explain this 1/3.